So today we will cover the learning outcome 1 of design technology, which is to demonstrate knowledge and understanding of engineering products and design. So in this session, we will be covering discuss the triggers that simulate engineering design activity, evaluate commercial, regulatory, or public policy-based trends that challenge current technology or design, and discuss sustainability issues in product design process. So the first learning outcome is to discuss the triggers that stimulate engineering design activities. So in this, the first factor is the market pull or the technology push. So the market pull, it basically refers to customer demand. So basically, what is the customer demanding, or the market trends that create the need for improved products or processes. So the engineers respond by designing solutions that cater to these demands. For example, one of them could be like the push for electrical vehicles. So there is a demand for alternate renewable sources of energy and something away from traditional fuels. So electrical vehicle could be one of the example of market pull. And then you have technology push. So technological advancements, they inspire engineers to create innovative products, processes, even before a specific market demand rises. So for this, an example could be the use of blockchain for use of technology which is used for cryptocurrencies. So there was no demand for it, but still the technology was developed and the technology push was provided, and which has led to a large-scale adoption and interest in Bitcoin and other cryptocurrencies. The next factor is the demand. So whenever there is a surge in demand for a product or process, the engineers may design ways to scale up production or optimize processes to meet this demand efficiently. For example, if there is a demand for cars, or for example, we can take, there was a huge demand for masks during the COVID-19. So this demand was fulfilled through Amazon and other e-commerce players. So when there was a surge in demand for the product or process, and then the engineers, they scale up production or they optimize processes to meet this demand efficiently. Then the next factor is profitability. So profitability is the governing factor for all the companies. For all the profit-making companies, they want to make profits, and the maximization of the wealth of shareholders is one of the key criteria for all the CEOs and the managers. So the prospect of increased profits can drive engineers to design cost-effective solutions, streamline processes, and create products with higher profit margins. So when they see products which can generate larger profit margins, then these are the triggers that stimulate engineering design activity. Then the next thing is innovation. So the desire to push the boundaries of what is possible and create novel solutions. It motivates the engineers to engage in design activity and often leads to breakthrough innovations. So this is one of the main triggers. So you can see innovation in many things, like you have the digitalization, digital transformation. You can see Internet of Things. You can see blockchain. You can see artificial intelligence. And for example, ChatGPT is one innovation over the normal search engine. So it can be considered as a personal assistant. So basically, it is the desire to push the boundaries of what is possible and create novel solutions for the customers. The next factor is market research. So insights gained from the market, or probably the feedback gained from the market, it helps the engineers to understand the consumer needs, preferences, and pain points. So where exactly is the customer facing a problem? Is it the delayed delivery of the product, or is it the product features are not good enough, or the price is very high? So this data informs the design of the products or processes that align with market requirements. So the engineers, they receive the feedback and then they work on it to improve the design. So this is all based on market research, which is one of the triggers that stimulate engineering design activity. Then we have product or process performance issues. So engineering design activity is also triggered by when existing products or processes face performance issues. For example, laptop is one prime example. Like the computing power is increasing. If a person who is using 4 GB RAM will have a very slow laptop, the processes will run very slow. So the performance is has what motivated the engineers to develop uh, uh, higher RAM laptops, for example, 8 GB or 16 GB RAM. So the engineers work to identify and address these issues through design improvements. So, so this is the product or process performance issues is another of the triggers that stimulate engineering design activity. Then we have sustainability. So it could be carbon footprint, it could be business sustainability. So growing environmental awareness, it drives the engineers to design products and processes that are eco-friendly and have reduced carbon footprint, aligning with sustainability goals. So you could have the recycling could be handled in a sustainable way, or you could have a circular economy where whatever is being recycled can be used in the products. So that way, sustainability issues is another trigger which motivates the engineers to stimulate the engineering design activity. Then the other factor is the designing out risk. So this essentially relates to the need to minimize or eliminate potential risks in products and processes that can lead to design activity focusing on enhanced safety, reliability, and robustness. So one prime example in this could be mining operations, where you have to go to underground mining, which can be very dangerous for humans. So the sensors or the machines which are driven by sensors can be used to minimize or eliminate potential risks for the human beings, and they can assess. So the machines can they can carry out the mining, and they can carry out the dispatch and logistics, thereby reducing the need for human intervention. So that is another trigger that stimulates engineering design activity. So we have looked into these factors. So next we will look into the commercial, regulatory, or public policy based trends that challenge current technology or design. So one of the key factor is reduction of energy wasted during design. So whenever any design is being created, there is lot of iterations, there is lot of discussions, there is lot of testing is to be done. So what engineers can do is to employ energy efficient design tools and software to optimize product performance. So the software, they can clearly show how much energy is being utilized, and accordingly, the engineers can program the software to optimize the usage of energy and work on products which are energy efficient. So this can be done by using simulation and modeling techniques to assess energy consumption and identify areas for improvement. So the simulation and modeling, it presents the different scenarios wherein, for example, if one equipment is off, the other equipment is on. So what will be the energy savings? So that way, or if both the equipments are running in parallel, or if one equipment is running at peak, the other equipment is running at 50% of its capacity, then what is the energy consumption? So accordingly, the scenarios can be designed, and simulation and modeling can be used to assess energy consumption and identify areas for improvement. Then you have to choose materials with lower embodied energy and consider life cycle analysis to minimize energy waste. For example, we can use materials which are easily recyclable. So that can be used in the engineering design, or then you can have the need to reduce the one single use plastics, which takes a lot of time for degradation and causes a lot of environmental issues. So the reduction of energy wasted during design is one of the key factors which challenge the current technology or design. Then you have to optimize the product design to minimize energy losses during operation. So this is the continued version of reduction of energy wasted. So the product design is optimized, then the energy losses will be reduced. So again, how this optimization will occur to see there are no excess energy uses. For example, if you are using a phone, so in the backend, many apps are running. So if the system can automatically close those apps when those are not needed, then it can save a lot of battery. So if it saves battery, then you are less likely to recharge the mobile phone, or you will be recharging it for a lower time. So that way, you're going to save energy during the operation of a cell phone. Then incorporate energy efficient components such as motors, sensors, and control systems. So all of these electronic control systems, they generally are, they have a energy efficient reading in them. So when you run those, the monitoring interface, it will show how much energy is being used. So for example, if the operation is in downtime, then you can shut down the sensors so that energy is conserved during that time. Then you have to implement smart technologies for real-time monitoring and adjustment of energy consumption. So smart devices, it could be like you can have your home as a smart home, wherein you can switch off the AC when you are in a different room. So that way you can switch it off through your mobile phone. You can have a connected mobile phone, or if you are not using your geyser, so that way you can switch it off. So our smart technologies, it can do is like uh, after a certain period of time, you can switch off the AC automatically, or you can switch off the geyser automatically. So so all these are based on sensors, and you can monitor them on real time, and you can then accordingly regulate your energy consumption. Then reduction of physical dimensions. So if you have a larger uh, electronic device, or if you have a larger circuit, obviously you will be needing more amount of energy to run the device. So when you explore miniaturization techniques and advanced manufacturing methods, then you can achieve the optimal design, which will also reduce the energy consumption, which will also be efficient, and which will also be a compact size and can be presented to the customer. So reduction of physical dimensions is one of the key focus areas for the engineers, and there are challenges being faced in current technology. One classic example is that around 30 to 40 years back, a huge storage was needed, for example, say 15, 16 GB. Now you have it in the form of a thumb drive. You can hold it in your hand. But around 40 years back, for storing 16 GB, there was no technology. For even storing half of that, you need to have a storage half the size of the room. So that miniaturization technique has helped in cost efficiency, that has helped in energy efficiency. Then again, utilize lightweight materials and structural optimization to maintain strength while reducing size. So again, using lightweight materials, for example, the airlines industry is one of the pioneers in that. They have been exploring with different composite materials so that the functionalities are not compromised, and structural optimization is there for the manufacture of an aircraft, while it maintains strength and size is reduced, or the composition or it becomes lighter. Then reduction of product mass. So again, the design needs to be focused on lightweighting using materials like composites and alloys, and it can be utilized. The topology optimization can be utilized. In, for example, the design, the core design, and additive manufacturing can be used to reduce material usage. So you can have different composites, you can have a different composition of materials, to reduce the product mass, again, which will help in energy efficiency, or which can reduce the challenges in the current technology or design. So this is one of the trends, that is reduction of product mass is one of the trends. Then another trend is increase in component efficiency. So the redesigned components for better aerodynamics, heat dissipation, and reduced friction. So this is what I was talking about. This is being used in airlines and automotive parts. So the components are redesigned so that they can withstand higher heat, or they can transmit heat, or they do not like catch fire easily. Similarly, it is being used in laptops also, because higher processing, it comes with higher heating of the components. So the components are redesigned for better aerodynamics and heat dissipation. Similarly, advanced control algorithms and sensor integration for optimized performance is another key trend in increasing in component efficiency. So here again, I would like to cite the example of blockchain and Internet of Things and artificial intelligence, where advanced control programs and sensor integration are used for optimized performance. Then the next trend, which has established current technology design, is energy recovery features. So the regenerative braking systems and are here the energy storage is being used, and waste heat recovery mechanisms are being used so as to recover the energy that has been produced during the motion of the vehicle. And then design systems that capture and reuse energy that would otherwise be wasted. So in any vehicle, or you can say aircraft, or any such any such vehicles, you would have kinetic energy produced, you would have other thermal energy produced. So basically, systems can be designed that can capture and reuse the energy that would otherwise be wasted. So this is also a growing trend among the engineering community regarding the energy recovery features. Then another trend is to reduce the product life cycle costs. So so this has multiple implications. The first implication is the business implication, where organizations, they want to reduce the product life cycle so that they can get to the market very fast and they can showcase their product. Now, for this, they also need to consider the cost. So the first key aspect is to consider long-term durability and ease of maintenance during design. So when the product life cycle cost is to be reduced, you need to ensure that the maintenance of the component or the product is less. Otherwise, the customers would not be very happy paying a very high maintenance cost over the life cycle of the product. So this can be achieved by selecting materials and components with extended lifespans and reduced maintenance requirements. So again, the engineering community is dealing with challenges for producing such components with extended lifespans and reduced maintenance requirements. Now, the next trend is the integration of different power sources of vehicles. So, an ongoing trend is to design hybrid vehicles. For example, it can run by fossil fuels such as petrol, as well as with electrical vehicles, or with CNG as well as electrical vehicles. So, this can help in producing an efficient powertrain integration. Now, energy management systems can be optimized for seamless transitions between power sources. For example, it could use different types of energy sources, and it could easily transition at the push of a button. So that is one of the trend that is popular among the engineering community currently. Then the next trend is the reduced use of resources in high value manufacturing. Now, manufacturing is a resource intensive activity. So you need a lot of capital, you need a lot of human resources, you need a lot of materials for producing, and then you would have to test it, and then there are factors such as how much wastage is there, how much inventory loss is there, how much pilferage is there. So that is one of the key concerns among the engineering community, and one of the challenges that they are facing during manufacturing of different products. So this challenge can be addressed by employing advanced manufacturing techniques like 3D printing to reduce material waste. So 3D printing is a part of Industrial Revolution 4.0, wherein you have other components such as blockchain, you have artificial intelligence, you have machine learning, you have Internet of Things. So advanced manufacturing techniques such as 3D printing is cost efficient, and it basically reduces the wastage of materials. Then again, one of the key concepts in manufacturing is the lean manufacturing principles, wherein organizations maintain minimum amount of inventory so as to produce the required amount of product. So this essentially was first implemented by Toyota in Japan, and then it was followed by the different countries. The main idea for lean manufacturing is to optimize the resource utilization for the organization. Then the next idea is designing out risks for employees and customers. So we had discussed this in the last learning outcome also. So the safety needs to be prioritized, and ergonomic design needs to be prioritized to minimize the risks to employees during manufacturing and operation. For example, robots can be used in warehouses for uh, transferring goods from one place to another, or for oil and gas industry, you can use robots, or you can use machinery where they can go and do the survey, and they can carry out, they can bring in the sample from the geological sample. Or in mining, you can have machines which can go inside the mines and then start the mining process. So the key idea is to prioritize the safety and work on the ergonomic design so that risks for employees and customers is reduced during manufacturing and operations. Then to incorporate fail-safe mechanisms and redundancy to reduce risk for customers. So this again is one of the key trends which is being followed by the engineering community currently. Now, next is the third learning outcome. In the previous one, we looked at the different trends related to commercial and regulatory and the different engineering designs that are prevalent, and those that are being challenged by the engineering community. And in this learning outcome, we will discuss the sustainability issues in product design process. So the first thing is the natural resources and the raw materials. So as more and more consumption pattern is being increased by the individuals across the world, there is a natural resource depletion. For example, extracting non-renewable resources like minerals and fossil fuels, it depletes the Earth's finite reserve. For example, if you are mining for lithium, which will be used in the electric vehicle batteries, so that is a non-renewable resource. So probably after 50, 100 years, there will be no lithium. So that also needs to be considered. Then you have ecological impact. So for example, resource extraction can harm ecosystems, it can disrupt habitats and lead to soil erosion. For again, if you give the example of a mining industry, where you can have, when you do the mining, So it can lead to pollution of the water levels, and there can be major ecological impact also in the surrounding area. In some areas, you do mining in forest areas where you have to cut down the trees. So that also has an ecological impact. Then during manufacturing, there are different issues which needs to be considered for sustainability. So the first among them is the energy consumption. So manufacturing processes can be very much energy intensive and they contribute to greenhouse gas emissions. So this needs to be addressed quickly in order for the manufacturing operations to be sustainable. Then you have waste generation. So manufacturing generates a lot of waste. So recycling of this waste or proper waste handling is very important. For example, a chemical byproduct can pollute the soils and the water level, and it can harm the surrounding environment. So that also needs to be addressed delicately. The organizations should have adequate waste handling measures so that it does not cause environmental harm. Then you have water uses. There is excessive water used in mining, in manufacturing, and different other operations, which can strain the local water resources. So many surrounding community are dependent on only single one water resource, and if mining operations are carried out, it can drain out the water resources, which again presents a major sustainability challenge for the surrounding community. Then we have packaging and distribution. So excess packaging can lead to a lot of plastic waste and resource inefficiency. The plastics, as you know, it degrades in more than 100 years. So that is one main challenge. So this has to be addressed when we are looking into the sustainability issues in packing and distribution. Then you have transportation emissions. The long distance shipping and inefficient logistics can lead to large carbon emissions, which again can lead to ozone layer depletion and can cause environmental damage. And then single-use packaging. So single-use packaging contributes to plastic pollution and waste. So this is again presenting a lot of challenge for sustainable packaging and distribution for manufacturing operations. Then we have issue of use and reuse. So energy consumption. So energy used during the product's operational phase contributes to its carbon footprint. So if renewable sources of energy, for example, wind energy or solar energy can be reduced, this can contribute a lot towards addressing the challenge of sustainability. Then you have durability of the product. So products with short lifespan may need frequent replacement, so resulting in more waste. So that again needs to be handled, and organizations should work towards increasing the product life cycle as well. So one classic example is like purchasing of phones. So every 1 or 2 years, Apple comes out with a new model, and then people they go and purchase new phones. So or that is the case with any other mobile phone as well. So that again leads to more waste because all of these have to be recycled or destroyed, or some people they hold it in their homes or ultimately they throw it somewhere. So that again presents the issue of sustainability. And then maintenance. So products that are difficult to maintain might be discarded rather than repaired. So that again presents one of the challenges with respect to sustainability of the product. Then we have end-of-life product. So improper disposal or lack of recycling options can lead to landfilling and pollution of the product. So if there are no proper measures where the products can be degraded safely, then it can create a pollution and landfilling. Then you have toxic e-waste. So electronic waste contains hazardous materials that can harm human health and the environment. So proper handling of toxic e-waste is needed to address the issue of sustainability. Then you have the lack of recycling infrastructure. So many third world countries, they do not have a proper recycling infrastructure, which hinder proper disposal and material recovery. So this again is a major challenge in sustainability. So if you are not recycling it proper, or if there are no proper recycling options available, so that can uh, create a major threat to the environment, to the water table, to the soil ecosystem. So finally, the different strategies that can be used to address the sustainability issues include clean manufacturing. So basically, a good recycling system, use of renewable sources of energy. Then you have eco-friendly packaging, avoiding single-use plastics, or even avoiding plastics, which takes a lot of time to degrade. Then efficient distribution by the manufacturing companies. Then you have energy efficient products where energy can be conserved, or lower energy is needed. Then you have user education who can use the products more efficiently, repair and reuse. For example, if a product can be repaired and reused, then it saves a lot of energy, and a lot of environmental issues are saved because of that. So that if it cannot be repaired and reused, that means you have to go for a new product, which means the product life cycle is short, and then again same amount of more uh, energy will be used to produce the product. And then you have recycling programs wherein proper recycling should be done to ensure that it does not cause harm to the environment or the water table or the or soil erosion. And finally, encouraging circular economy wherein the products which are recycled can be used for manufacture of new products and sustainable material sourcing. So these are the different ways in which sustainability issues can be addressed in product design process. So that is all for today. In case if you have any questions, you can let me know.